The most typical kind of cardinality in a relational database management system is one-to-many, which is just as easily described as many-to-one. It just depends on which side of the relationship you start at. And the example I showed earlier was this, perhaps the archetypal one-to-many or many-to-one relationship, customer and order. One customer can have many orders, meaning one customer row can be associated with multiple order rows, but each order row is only for one customer. Now, creating these relationships depends on us having our primary keys defined first. If you're attempting to describe that we need to link from a row in one table to specific rows in another table, we need a way to get to those specific rows, and getting to a specific row takes a primary key. So going into this, we must have our tables with our columns and primary keys at least roughly planned out. Next, implementing a new one-to-many relationship requires a change to whatever table represents the many side of the relationship. So to relate customer and order tables, I don't need to change anything about the customer table. That's the one side. I need to add some extra information to the order table. And it's the key to the customer table, so customer ID. And this again is called a foreign key. It represents a column in this order table that is a key to a row in a different table. And these will specifically refer to one and only one row in the customer table. You might find the customer ID occurs more than once in order, but it's always pointing to only one row in customer. And we always make the change to the many side of the relationship because it's the only way to do it. I can add one column with one value to every order row that will always point to a correct customer. But I cannot add one column with one value to the customer row that could point to a variety of different orders. So we're making a match between the columns in these different tables. Now, very often we would use the same column name across both of those tables. So in this case, customer ID in customer ID in order. But it doesn't have to be the same because we are really making the match on the values in these columns. In some cases, you couldn't use the same name because there'd be a conflict. Perhaps both of these tables were defined with a primary key just called ID, or we couldn't reuse the ID column twice in the order table. There'd be a conflict there, it just wouldn't work. So we'd call it something else, like customer ID. It's still a foreign key, it just happens to have a different column name between the different tables. Another thing that you might see is a completely different name that attempts instead to describe the relationship. So instead of using customer ID, we might use something like placed by as a column name. An order is placed by a particular customer ID. It still refers to a value that's in the ID column in the other table, it's just using a different name. So the name of the column doesn't have to match, but the data type certainly should. It doesn't make sense to have a primary key that's an integer in one table try and match a column that's described as character data in a different table. Now, it's also very common to have one table that takes part in multiple relationships. So a customer can have many orders. We've got a one-to-many relationship here, but we may decide that our customers can have multiple different addresses they may ship to, so we might add a new table for address and have another one-to-many relationship between customer and address. This is perfectly acceptable and very common. Another option is that a table that is on the many side of a one-to-many relationship could be on the one side of another. So for example, order might be the many side of the customer to order relationship, but order itself could have many order items, so it's on the one side of that relationship. One customer has many orders, one order can contain many order items. Now, as we start to get a bit further, we're going to want to start to diagram these a bit more specifically. Now, I've shown the basics of entity relationship diagrams as they are very simple to just get started conceptually, basically boxes with lines between them. Although, as you start to more formalize the actual database diagram, you'll see a different kind of layout emerge. And there's no fixed one standard. You'll see different options used across different database management systems and different charting applications. But they usually boil down to this kind of idea. A box for each table with the name of the table at the top. Then we'd have the column names. You may or may not add a little extra to show what kind of data these are, character data, dates, binary, integers, and so on. What is very common is you would add a PK for a primary key, and you would add an FK to denote a foreign key, and then start adding the relationship connector lines between them. And this kind of diagram is very, very common across all relational databases. It's easy to see what tables exist, what columns, what relationships exist between the tables. Now, in most relational database management system administration software, there is an option to generate these diagrams from an actual existing database in that server. And the relationships themselves will be shown with these connector lines. Different software tends to generate different looking lines. As I mentioned earlier, some will use the crow's foot style to show the many part of a one-to-many relationship. Some will show the infinity symbol. There are other ways of doing this, but it's usually not that difficult to pick any one relationship and figure out which way it's going.